In this lesson, we're going to take a look at how to correctly identify the number of significant figures in data when it has been recorded. A previous lesson was provided on the significance of significant figures, or their meaning and definition. It may be helpful to go back and review that lesson. When data is recorded, some of the information related to how well the measurement was conducted is communicated. This is reflected by the number of meaningful digits that have been recorded, sometimes referred to as the significant digits or significant figures. The more significant figures in data that has been recorded, the better the measurement is generally assumed to be. Looking at the two measurements below, 1.52 meters versus 1.5 meters, since these are each made of all non-zero digits are always considered significant parts of a measurement. Therefore, 1.52 represents 3 significant figures, while 1.5 represents 2. Any non-zero digit is always considered significant to a measurement or a significant figure. Data with 3 significant figures is somewhat improved from data that would only contain 2. This would relate to the type of device or devices used to make each measurement. A more sensitive device would be needed to measure 1.52 meters versus 1.5 meters. It's generally not a problem to understand that all non-zero digits are significant to a measurement. The complications come in how to treat zeros when they are part of a measurement. We can see that there are zeros of various types that help us remember how to identify the number of significant figures. Let us take a look at each type of zero. Let's first look at what I like to refer to as East Coast zeros. When looking at the decimal position, the East Coast is referred to as to the right of the decimal. Therefore, each of these zeros are what we would call East Coast zeros. East Coast zeros are always considered significant and relate to the measurement as being a much more sensitive measurement than if they were not there. This particular measurement has 6 significant figures in it because it has 3 East Coast zeros and 3 non-zero digits, the 1, 3, and 7. Compare that to an amount written as 137, assuming that maybe we were measuring feet for each of these. 137 would only have 3 significant figures. A measurement made of 3 significant figures is far less precise and perhaps even less reliable than one with 6. Therefore, East Coast zeros can be thought of as zeros to the right of the decimal, or a 0 to the right of a decimal, or strings of zeros to the right of a decimal. Let us take a look at what I like to refer to as sandwich zeros. In the measurement written below, 107 millimeters, you can see the 0 is sandwiched between a 1 and a 7. When a 0 is sandwiched between other significant figures, it is considered significant to the measurement. Therefore, this represents 3 significant figures. In the value reflected below, 130.0 liters, we can see that there are 2 zeros in this particular measurement. One of these zeros happens to be an East Coast zero because it is to the right of the decimal position. Recall from a moment ago, East Coast zeros are considered significant to a measurement. Since this East Coast zero is a significant figure and the 3 is a significant figure, this zero then becomes a sandwiched zero, sandwiched between the 0 and 3, considered significant to the measurement. Therefore, this has 4 significant figures. The 1, the 3, and both of the zeros. Let's now take a look at zeros that are considered not significant to a measurement. Sometimes we refer to these as holding the decimal place position to give the numbers or digits their true meaning. Let us first take a look at leading zeros. Some folks like to also refer to these as West Coast zeros because they are to the left of all of the other digits in a measurement. Here we see a string of West Coast zeros or leading zeros. All of these zeros simply communicate what the value of the 5 and 4 truly mean, since the 5 is in the 4th decimal position, also known as the 10,000ths. Since leading zeros are not considered significant, only the 5 and the 4, the 2 non-zero digits in this particular measurement, are considered significant to the measurement. Therefore, this measurement contains only 2 significant figures. Recall, when there are less significant figures, a measurement tends to be less precise and perhaps even less reliable. As we add more significant figures, the measurement becomes somewhat more precise and perhaps even more reliable. The term leading zeros is sometimes just to refer to zeros or strings of zeros that lead the digits of a measurement. Let us take a look at what is meant by trailing zeros. Trailing zeros are also not considered significant to a measurement. In order to understand trailing zeros or the meaning of them, typically there would not be a decimal written to identify trailing zeros. We can see the measurement 5,000 grams has no decimal position where we might assume one to be. These zeros can therefore not be considered significant to the measurement because they are considered trailing zeros. Each of these trailing zeros therefore do not count as significant to the measurement. Therefore, only the 5, the non-zero digit, counts as a significant figure. This particular measurement is made up of 1 significant figure. Another way to view what we called sandwich zeros before would be to think about the decimal and the 5, in this case sandwiching these zeros. Therefore, the measurement written this way is made up of 4 significant figures. It seems like a subtle difference, but this is really intentionally meant to communicate how well or how precise a measurement was conducted. Let us take a look at a few examples to reinforce these ideas. Looking at example A, we see that there are 2 digits to the left of the 1. Each of these are what we like to refer to as our leading zeros. Therefore, they are not considered significant to the measurement. Since the 1 is a non-zero digit, it is considered significant. The 0 between the 1 and the 5 is a sandwich zero, which is also considered significant. The 5 is a non-zero digit, considered significant. And the 0 at the end is what we would know as an East Coast zero. It is not considered a trailing zero because there is a decimal in this case. Therefore, this is made up of 4 significant figures. Comparing to example B has a 3 and a 2, both non-zero digits, which would be considered significant. And it has what we would know as a trailing zero because no decimal position appears in this particular measurement. Therefore, this is made up of 2 significant figures. Looking at example C, we see a 1 and a 5, both non-zero digits, which are considered significant. And we also see 2 zeros to the right of the decimal, which sometimes we like to refer to as East Coast zeros. So these East Coast zeros are also significant to the measurement. This contains 4 significant figures. Look at example E, we see a number of different zeros in this example. The 3 and the 8 are both non-zero digits, which causes this zero to be a sandwich zero, also significant. The 8 and the 1 happen to sandwich this zero, and the 0 on the end happens to be what we like to refer to as an East Coast zero. Again, the reason this is not a trailing zero is that there is a decimal in this particular measurement. Therefore, each of the digits in this measurement are considered significant. This measurement contains 6 significant figures of information. Comparing to example F, 4,200 miles, there is no decimal position in this particular measurement recorded. Therefore, we consider these to be trailing zeros, which are not considered significant to a measurement. This measurement therefore contains 2 non-zero digits, which are always considered significant. I hope you found this lesson useful for identifying the correct number of significant figures in data. It may be useful to refer back and stop and compare this to information that perhaps you are trying to deal with in examples from practice. Recall the purpose of significant figures is to communicate how well a measurement was conducted, which sometimes relates to how reliable data is, and how well measurements can relate to decisions that must be made about the reliability of the information. There may be one other thing to consider when we talk about significant figures and information. One of those ideas relates to counted items that are not typically thought of as measured amounts. For example, if a package of bottled water came with 40 bottles, that's not considered a measurement, that's considered a counted amount. We don't consider the number of significant figures to be related to any idea in this particular measurement or this particular amount. We would consider there to be an infinite number of significant figures in counted items. Likewise, 12 students. Students would be counted items. Therefore, we do not consider this 2 significant figures, we consider this to be an infinite amount of significant figures. Significant figures should be reserved for measurements that have been recorded using devices and not counted items. This seems again to be a subtle difference, but it's important sometimes to deal with information in the best way possible to allow decisions to be made, and significant figures sometimes help those decisions be made related to the reliability of the data.